Let's have a look at an example calculation of isotopes. So here we have two isotopes, oxygen 16 and oxygen 18. And I've got a little very bad snippet of the periodic table of the oxygen element, and it tells you the atomic mass number and the proton number or the atomic number, which are going to be very useful pieces of information for us to calculate the number of protons, neutrons and electrons for our two isotopes. So we have our oxygen 16. So this is the mass number of our oxygen actually. And just remember that the mass number tells you the number of protons plus the number of neutrons, and we have oxygen 18. And for both of them, the proton number will stay exactly the same, because just remember the definition of isotopes is that isotopes are atoms of the same element that have the same number of protons and electrons, but they have different number of neutrons. So your proton number in this case is going to stay the same, so it's going to be 8 protons for oxygen 16, 8 protons for oxygen 18. So let's see if we can fill in this table really quickly. So in this case, 8 protons for both of our isotopes. Electrons is going to be the same, because remember the same number of positive subatomic particles I must have the same number of negative subatomic particles. It's also going to be 8 electrons for both of our isotopes, and the only difference is going to be when it comes to our neutrons. So remember to work out the neutrons. In this case we need to do 16 minus 8, which is going to be 8 neutrons for oxygen 18, and in this case it's going to be 18 minus 8, so it's going to be 10 neutrons for our oxygen 18. So we have the same number of protons, same number of electrons, but different neutrons. And here is just an example of how to do this calculation.